All right, my friends, getting started. Let's start by graphing vector u. And remember, if that you see those brackets, then it's assumed that the initial point is at the origin, and then the terminal point is at whatever coordinates are given there. So also remember, if you're going to have more than one vector on the same plane, you should always label which one's which. There we go. So that would be vector u. Also make sure that the tip of your arrow is at the 0.34 and it doesn't go beyond it. Okay? All right, now let's figure out vector v. Well, the definition of vector v was given as 2 being multiplied by vector u. Well, that would be like 2 being multiplied, and then I'm just going to substitute the component form of vector u in. So if you guessed that with a scalar multiple like this, you just distribute it into both the x component and the y component, then you were dead right. There we go. And that's a quick little explanation as to why we would say vector v would have component form 6, 8. So the vocabulary, we would say in this case that 2, when you multiply a vector by a constant, that constant is called a scalar. Well, and that's part of the reason that I had you graph both of them on the same plane. So let's see, let's go to 6, 8, which is a little off my picture here. But notice when you multiply a vector by a scalar, like in this case it was 2, you could have multiplied by any scalar. Notice what multiplying by a scalar changes and what multiplying by a scalar, doesn't change. First, let me label this correctly. Okay. So when we multiplied vector u by a 2, and it scaled it up by a factor of 2, what did it change? I claim that it changed its magnitude. But what didn't it change? I claim that it didn't change its direction. And that's something worth kind of making note of, is that scalar multiplication I'm going to put in parentheses by a positive scalar anyway. Changes the magnitude of a vector, but not its direction. There we go. And we're going to actually compound upon that little fact as we go. Okay? All right. And if you weren't sure how to finish this problem, then read that note really carefully and see if you can use that in your problem solving to figure the rest out. Okay. Now for part B, it says draw a unit vector that has the same direction as vector u, and we're supposed to call it vector w. Okay, so first let's talk about what is a unit vector, and we will add that definition down here. A unit vector. I'm going to leave the part that it being a vector is implied, so is a vector, and we'll just say it has magnitude or length of 1. There you go. So if that's what you thought a unit vector was, then you were dead right. It's just a vector that's 1 unit long. So if I was to draw vector u, vector w that is, it's supposed to have the same exact length as vector u does. So it should follow the same path, but it should only be, 1 unit long. So kind of look at, you can see here on the graph paper what 1 unit is. And so I'm going to use a second color here. So I would say maybe it goes to about there. I'm going to zoom in on it so you can see. So it's only 1 unit long. It starts at 0, 0. And then goes for 1 unit past that. There we go. And that's going to be vector w. Okay, so I just drew it. So for part B, I'm supposed to draw it and then, and that's it. Okay, for part C, though, I'm supposed to find its component form. So there are different ways to do this, but let's think about this. If scalar multiplication, my friends, doesn't change the direction, but it just changes the length, let's just kind of put this together. And I want basically to take vector u, which currently vector u has a length of 5 units. I hope that makes sense, because it was like a 3, 4, 5 triangle that you could use to find the length. So vector u has a magnitude of 5. So what would I have to shrink vector u down by to turn it into something that's just 1 unit long? So I hope it makes sense that once I know the magnitude of vector u, if I want to shrink it down to be just 1 unit long, I could take vector u and multiply it by 1 over its own magnitude. So in this case, I would multiply it by 1/5 because it has a magnitude of 5 or a length of 5, and I'm just trying to shrink it down. So anyway, at that point then, you would just be multiplying 1/5 by 3/4, so you'd get 3/5 and 4/5. There we go. And if you look at the picture, does it make sense that the endpoint of vector w could be at the point 3/5 for x and 4/5 for y? And I hope it is somewhat believable. I guess I should have put my work here. So vector w would be 1/5 of vector u, which would be like taking 1/5 and distributing it into 3/4, which would explain the 3/5, 4/5 answer that I got. There you go, just in case you needed an instant replay. There we go. Okay, now I want you to think about, what if, let's say I asked you, let's say vector u had a length of 29 units. Then what would I have needed to scale it down by to get it to be of length 1? What if vector u had a length of 42.3 units? Then what would I have needed to multiply it by to get it scaled down to be of length 1? And if you know the answer to that, then you're ready for part D. Write the formula for the component form of a unit vector in the direction of a given vector. So let's say you're given vector A. And let's say, what would you need to find first about vector A? You would need to find its length. And fancy for length is magnitude. So once you find the magnitude of vector A, what would you need to multiply? How would you need to scale vector A down in order to get it to be of length 1? Well, you'd have to scale it down by 1 over its own magnitude. Just like we did there with the 1/5 for something that was of length 5. There we go. So this would be a unit vector that has the same direction as vector A. So this is the formula for you. Formula for the component form of a unit vector in the direction of a given vector. There we go. All right, my friends, and that one was probably easier to think about because the magnitude was a nice, pretty number like 5. So for example 4, you'll find that the magnitude is, an irrational number. But go ahead and see how it goes if I ask you for part A to graph the vector on the plane, and so and then for B, find its magnitude, and for C, find the component form of a unit vector. We'll call that one V, that has the same direction as this one. See how it goes? Check in with me at the next video.